Hi everyone, welcome to Mernda Central Science Labs. I'm Marcus.
And I'm Betty.
And we're your
Lab techs.
Today we're going to investigate the cardiopulmonary system of a sheep by dissecting a sheep's pluck. What's the cardiopulmonary system, you ask? Well, to scientists, cardio means heart and pulmonary means lungs, which simply means we're going to be dissecting the lungs and the heart of a sheep. So the purpose of this experiment is for us to dissect the heart and lungs, to look at the structures, see if we can name some of the parts of those heart and lungs and what they do, and to try and understand how the lungs get oxygen out of the air and into our blood, and how the part then takes that blood and pumps it around to the rest of our body and to all the cells that require that oxygen. Alright, so to carry out our investigation or our dissection of this sheep's pluck, we need different sorts of materials. Obviously, we need to have safety equipment to start off with. So we'll have gloves on to keep our hands safe from the blood, because blood can be a toxic element of any sort of dissection, so you have to protect yourself from that. You clearly need goggles to stop splashes into your eyes, lab coat to keep your clothes clean. Apart from that, we'll need our dissecting instruments. So we'll need a pair of forceps, a sharp scalpel, a probe, and some scissors, and we'll need some straws to be able to show some of the passages through the heart later on. And to demonstrate that the lungs are actually full of air, we'll also need an air pump and some plastic tubing. The air pump and some plastic tubing, you'll see later what we use that for. So they're the basic materials we need for things, and we'll also have our friend here to help to explain some of the things that we're looking at, because they're not always that clear when you're looking at the real thing. So to start off with, we're going to dissect the lungs, and before we do that, we'll just get you a bit familiar with where the lungs are in the body and what they look like. So my friend here, the two red structures at the front here, or the two red organs at the front here, are the lungs. And in a minute when we show you the pluck, you'll see they don't really look the same, but we'll explain that when we get to it. Now underneath the lungs, if you take the lungs off, you have the heart, which sits in the centre slightly to the left. And underneath the heart you have the liver, which is this big black structure or big dark brown structure here. Okay, so this is a sheep's pluck here that we've got from the butchers. Now the sheep was killed for food, so we're not killing it just for the pluck. And you might notice straight away that it looks very different to what the model that I just showed you looked like. Now there's a reason for this. Inside an animal, the lungs are actually held out by the ribs, and they're held out in their full shape of the lungs. Once they're out of the animal, the lungs collapse and all the air pockets inside empty. We'll show you in a minute how you can re-inflate them to show you what they look like. So, just like in the dummy, you've got the lungs on top, underneath you have the heart, and below you have the liver. Now to show you what the lungs look like inside the body, we're going to get our air tube here to connect to an air pump. We're going to find the windpipe or the trachea, which used to be where the animal breathed through. And then we'll start pumping, and you'll see that the lungs will actually start looking a bit like what they looked like before in the dummy. There we go. So now all the little air sacs inside that spongy tissue of the lung are now full of air, and that's what they would look like when they're actually in a living animal. Okay, to start off the dissection, we're going to remove quite a bit of this connective tissue that's all over the front of the lungs here, so we can actually see things a little bit better. In the body, this connective tissue actually holds all the lungs and the heart and everything in place in the body, so it doesn't move around. So it's very important. But when you're dissecting, it actually can make it quite difficult to see what you're doing. So to start off with, I'm going to snip off quite a bit of the connective tissue so that we can actually see the structures that we're looking for. Okay, so to start off with our lung dissection, we need to find where the air came into the lungs. Now if you want to zoom in on that a little bit, we'll just show you that. That's where the windpipe or the trachea used to join up to the lungs. Unfortunately it's been cut off by the people who took it out of the sheep, but you can still see the entrance of where the windpipe used to connect to the lungs there. Now what we're going to do, we're going to try cut a cross section of the lungs through all the air vessels or air pipes that go into the lungs. Obviously the air pipes that go into the lungs here are much, much larger than what they would be at the very edge of the lungs, where they're actually microscopic. So to get from there to there, you need to form a tree-like structure. So imagine a tree. This is the trunk of the tree, and as it goes in, the branches divide more and more and more until they get to tiny little twigs inside the lungs here, which connect up to little air pockets called alveoli. Alright, so what we're going to do, we're going to actually use a scalpel. Now scalpels are very, very sharp, so you have to be very careful with scalpels. And we're going to slice down the side off the windpipe here. And we're going to try actually open up the windpipe along those branches I was talking about and show you what a bit of the tree structure looks like, at least. In a minute, through the magic of video, we'll actually stop and then we'll start again when we've got a bit further on. Okay, so this is one of the lobes of the lung that's been opened up, and this is where the trachea used to come in, through this section here. It's been opened up, and you can see that's the main passage going in. As it goes, it divides into smaller and smaller and smaller passages. We can't open up all of them, obviously, because they're very, very tiny passages, but if you look carefully, you can see where other smaller passages go off the ones that we've opened up already, and they would divide again and again until you end up with passages that are so small that you can't actually see them. Okay, so now I've got all the air passages opened up and we've shown you how they branch out. When you actually inflate one of the smaller air passages, you'll notice that only a small part of the lung will inflate now, showing you that it's a part that is getting towards the end of those tree branches I was talking about. If we inflate a different section, we'll say a different section of the lung will inflate, or if we inflate another branch, you'll see another section of the lung will inflate. So all these little arms are spreading the air tubes out through the lung, and they end up in those little tiny air sacs called alveoli. Now the alveoli you can't see without a microscope. They're all through this pink tissue here, and the reason the tissue is pink is because it's also full of blood, or blood vessels. Now the blood vessels surround those little air sacs called alveoli, and the air can actually dissolve, or the oxygen can dissolve out of the air sac into the blood vessels and be carried off to the heart to be pumped around the body. And also the carbon dioxide coming from the body, which is a waste product, can dissolve from those blood vessels in this pink tissue back into those little air sacs to be carried out through the air tubes back out to the mouth and out of the body again. This diagram shows the airway we've just been looking at. The trachea, which divides into the bronchi, which divides further into the tiny bronchioles, which end in the air sacs called alveoli, which are microscopic. Okay, so the last part of the lung dissection, after seeing all the branches of the airways, is to try see if we can spot the blood vessels coming out of the heart and into the lungs. So they're not actually all that easy to spot, but there's one of them there. That will be the, if I lift it up a little bit, you might be able to see the slightly muscular walls of the pulmonary artery. Now the pulmonary artery takes blood into the lungs, and the pulmonary vein, which is actually much harder to spot, which I don't think I'll be able to spot easily, which will be down here somewhere, it takes the blood back to the heart again. Now, the interesting part about the pulmonary artery when it comes out of the heart, it's carrying blue blood, blood without oxygen in it, because it's come back from the body, all the oxygen has been used up, and it's going to the lungs to have the oxygen put back into it. So the only arteries in the body which carry deoxygenated blood or blue blood are the arteries going from the heart to the lungs, the pulmonary artery. Now, just before we finish on the lungs, a quick thing about the pluck. Pluck usually include a liver, heart and lungs. Now, we know what the lungs do, hopefully now. We've seen a bit better about the sorts of things that help them do their function. The heart is going to be the next thing we're going to look at, which is the pumping system for the thing which moves all the blood around the system. And the liver, which we're not going to dissect this time, is there for one very important reason. The liver actually controls how much sugar is in our blood, amongst other things, but this main function is to control the amount of sugar in our blood. Sugar in our blood actually can kill us if we have too much of it. And what the liver does, it gets told by the pancreas using insulin to actually store the sugar away in a way that's not poisonous to us. And then when we don't have enough, and if we don't have enough sugar, it can actually kill us as well. It then gets the liver to release sugar back into your blood. So that's the main function of the liver. It also gets rid of toxins in your blood and a few other bits and pieces like that, and produces bile for digestion. But the main thing is it controls blood sugar levels. Okay, so before we dissect the heart, there's a couple of things I need to explain about how we talk about the left and the right of the heart. Now, when we talk about left and the right of the heart, we're talking about the left and the right as it would be for the person. So the front of the heart's there. If we look at the heart there, if we pull it out like that, the coronary artery runs across the front of the heart. And for this person, their left is on this side, their right is on this side. So that's obviously the left side of the heart, that is the right side of the heart. But when you turn it around and look at it, it appears to reverse. Alright, so that's the heart as it would be in my chest like that. So that's the front of the heart. So obviously that's going to be my left, that's going to be my right. But when we put it down, when we're looking at it from the front, the sides have been reversed. So that is now your left ventricle or left side of the heart, that is now your right side of the heart. Alright, so the parts of the heart, we'll go over them very quickly. Alright, so this side of your heart, which is big and bulgy, is your left ventricle. The left ventricle is the part that pumps all the blood to your body, so it has to be big and muscular. The right ventricle is the other side of the lower part of the heart, which is the one that pumps the blood to your lungs, which isn't as far, so it doesn't have to be as big. The tip of the heart's called the apex. The line going down the middle, diagonally across here is your coronary artery. Now, you've probably heard about the coronary artery. It's the one that gets blocked when people have heart attacks. And the interesting thing about heart muscle is that it can't go without oxygen for any length of time whatsoever. So if the blood stops flowing to the heart muscle, it dies, which is what causes a heart attack. If you block that blood vessel enough or completely, the heart dies completely, and of course, whoever's heart it is means they die as well. Okay, so they're the ventricles. Now, anyone who knows anything about hearts knows there are 4 chambers to the heart. The top chambers, unlike the bottom chambers, which are really muscular, are only very, very thin. So the atrium, or atria, or atrium for each one, are these funny little brown bits on top here, which are basically little thin sacs, which collect the blood coming from the body and collect the blood coming from the lungs before it passes it on to the ventricles below. But we'll look at that in a minute. So they're the atria or atrium. So that's the left atrium. And on the other side here, it's a little bit tucked away somewhere. A bit hard to see, but that is the right atrium there. Now, we've got the right atrium open there, and you can see there's a great big opening going into the top of that. Now, the right atrium collects blood from the body to be passed on to the lungs for putting oxygen back into it. So that is actually the vena cava coming in from the body into the right atrium, which is going to be passed into the right ventricle before it gets pumped to the lungs. So that's the vena cava. Now, the other big vessel coming out of the top here, this one here, you might see there's two attached to each other by connective tissue, but this one I'm holding at the end here. You can see the big opening there. It's a much thicker blood vessel, very muscular. That is the aorta, or the main blood vessel that goes to the body, and it carries all the blood to all the parts of the body that the body requires to stay alive. Now, on the other side of it, you have another very muscular looking blood vessel. You can see that one there. That is the pulmonary artery, and the pulmonary artery carries the blood that has come back from the body to the lungs to get oxygen put into it and to have carbon dioxide taken out of it. So they're the main blood vessels. So the pulmonary artery, the aorta, the vena cava, and if you look here, which actually goes into that left atrium, is the pulmonary vein, which is bringing blood back from the lungs full of oxygen to be ready to be pumped into the body. Okay, so to dissect the heart, now that we've identified all the parts, we need to look at the coronary artery which runs diagonally across here. Now, the left ventricle, about halfway between the side and that coronary artery, we'll do a cut down through there. We want to open up the left ventricle first. First thing we want to do is find out where the cavity of the left ventricle is, so we can see the left ventricle inside there. And we'll do the same for the right ventricle. Now, the right ventricle you don't cut quite as far over, so about a third of the way between the coronary artery and the side. And again, you slice down through there until we find an opening here, so which we've already found because it's not as muscular. So we'll just cut down a bit further. So that's your right ventricle there, which pumps the blood back to the lungs. Now that we've found the two ventricles, what we're going to do a cross-section of the heart. So we're going to actually take the top of the heart off, and we're going to then expose both sides so you can see the difference between the two. And we'll just peel that back for the moment. So we can start seeing the left ventricle and the right ventricle. Alright, so we'll just take a little bit more off here before we open up the top chambers. So you mightn't be able to see this the whole time while I have my hands in the way. Alright, so first things first. So we've got the bottom chambers opened up here a little bit. We might just open up this one a little bit more. Use scissors this time because it's sometimes easier to use scissors. Okay, so first thing to notice, this part's fallen over a little bit, so we'll just lift that up a little bit so you can see it a little bit better. Alright, so these are the bottom chambers of the heart. A couple of things to look for to start off with is the thickness of the walls. So this is the heart muscle. Notice how around the left ventricle the heart muscle is really thick, and around the right ventricle the muscle is quite thin. The reason for this is because this particular ventricle is pumping out of the aorta and to the body and needs to be really muscular and strong because it's got a long way to pump the blood, so it must be much stronger than the right atrium, which is only quite thin and has much less muscle because it only has to pump it to the lungs which surround the heart itself. Okay, we've cut the heart cross-section, although we've cut a little bit much off the right here. The left ventricle is this nice muscular chamber here, and at the top of the ventricle is a valve called the bicuspid valve, and the bicuspid valve stops the blood from flowing back in the wrong direction, so the blood coming back from the lungs comes through that valve and then through the valve, and then allows it to be pushed out into the body through the aorta. Now, if you look really closely, you'll see something called chordae tendineae, which are these little strings, and you might have heard the term heartstrings. Well, that's where the term heartstrings come from, and those little strings there hold the valve in place and help it to operate correctly. On the side we've opened up more widely, you can see quite a lot of those chordae tendineae. They're little, basically like microscopic tendons inside the heart for holding things together. Now, on the left ventricle here, which is going to be easier to demonstrate, if we go up to the top of the ventricle and to the left-hand side slightly, you'll find there's a passage that goes straight up through what we showed you as the aorta before. So we know that this chamber pumps from this chamber out through the aorta to the body. So this is the chamber pumping to the body. If we get another straw, we can push it through to the top of the chamber, through the tricuspid valve and into the atrium. Now, it's a little bit difficult to find, but there is a blood vessel up there. We'll see how we go. There we go. So that is the passage. So this little section here is the atrium, which puffs up when it's full of blood. We've got the vena cava coming in here, which is the vena cava coming in here, which is the not the vena cava, the pulmonary vein coming back from the lungs here, full of oxygenated blood. It passes down the passage between the atrium and into the ventricle to be passed into the ventricle here, and then the oxygenated blood is passed out through the aorta into the body. On the right, the blood enters into the right atrium through the vena cava. It then passes through the tricuspid valve into the right ventricle before being pumped to the lungs through the pulmonary artery. Left ventricle, much more muscular because it pumps to the heart, to the body, because the body is much further to go for the blood. Right ventricle pumps to the lungs, which are around the lungs, so it doesn't have to be quite as muscular. You have chordae tendineae, which are the heartstrings, which actually locate the valves and hold the valves and help the heart keep its shape. The middle section is called the septum, which is simply just a dividing wall between the two ventricles. Sometimes in people are born with a hole in this septum here, which allows blood to flow between the chambers, which means they can't pump their blood properly, and they often have to have a heart operation to fix it. At the top is the bicuspid valve in the left ventricle, the tricuspid valve, which has been cut away here, in the right ventricle. The atriums are far less muscular. They only collect the blood, so they don't need to actually have much muscle at all, because all they do is pass it down to the ventricles. And the aorta, which is a thick muscular artery coming out of the heart, is the main blood vessel carrying blood to the body. The pulmonary artery, which is this one here, is the one carrying it to the lungs. And of course the veins are much thinner and larger, and they carry the blood back to the heart from both the lungs and the body. Just to finish off our heart dissection, we'll just have a quick look at the model of the heart. If we pull the bottom of the heart off, you can see it's basically what we were trying to do with our dissection, doing a cross-section through those two bottom chambers, the left ventricle and the right ventricle. You can see the heartstrings, or the chordae tendineae, which are attached to the bicuspid valve on the left ventricle and the tricuspid valve on the right ventricle. You have the valves going out from the right side into the pulmonary artery and from the left side into the aorta to the body. This is the right atrium here. The right atrium connects to the vena cava, which is the main blood vessel coming back from the body, carrying blood that has no oxygen left in it and has lots of carbon dioxide in it. The right atrium is quite large, so it has to bring back lots of blood from the body. The blood then passes down into the right ventricle, and from the right ventricle it will then go through the pulmonary artery to the lungs to be reoxygenated, or get oxygen put back into it and to get rid of the carbon dioxide. If we then go on to the left atrium has the pulmonary veins coming into it. Now the pulmonary veins are the only veins that are going to carry oxygenated blood because they've come from the lungs. And they come into the left atrium, get passed down to the left ventricle, and then it gets pumped from the left ventricle with those really big strong muscles out through the aorta and to the body. So that's our heart dissection. I hope you've learnt something about the heart and how it works and where it takes blood to, and hopefully at some stage you'll get to do your own. Alright guys, that's it from Mernda Central Science Labs for now. Bye from me, Marcus.
And bye from me, Betty.